Afternoon, everyone, or good morning, depending where you're logging in from. We're going to walk through and take a look at some of these ideas behind generative design. And it's not a super new idea. It's been around for a few years, but it's really interesting some of the changes that we've seen with it as it's come along and what we're looking at. So as if you've been on one of these before, we usually talk a little bit about who we are a little bit. So Rand Worldwide, Imagine It, who Gladys and I work with as part of a Rand Worldwide company. And what Imagine It does is we're a leading provider of Autodesk solutions, Archibus, Leica Geosystems. We do professional services, and that's really the group that I'm part of, professional services and training. And then we also have a couple sister companies. So Rand 3D, which is a leading provider of Dassault software and Dassault and PTC training. And if you've taken a AutoCAD or Inventor class in the past, I'll say 15, 20 years, you probably used an Ascent book to do it. And that's another sister company of ours who creates the courseware for those. And they create the training materials for Autodesk, PTC, and Dassault. So Imagine It is one part of this larger company, and I've been here about 20 years, and I am one of those little dots there. Notice that big cluster there in the Midwest. I'm out of Toledo, Ohio. And I always like to show this map. I've been doing this for years and years, and this map just keeps getting more and more pins on it. But I just wanted to give you a sense of our geographic reach, the different areas that we're in. Each one of those represents an office, and it gives you a sense of how wide we are. But I also want to talk to it about how deep it goes. So most of those locations have technicians at them. So we have training centers, and then we also have technicians. So I'm in charge of a team of 6, kind of spread throughout the Midwest. And then I've got counterparts in the West and a counterpart up in Canada. So that we have this range of people that we get to talk to, pull ideas from, discuss different methods with. And it's always interesting to talk to a lot of them because we have so many different ways of doing things. It seems like, anytime, I always say if you get 6 people in the room, there's 12 different ways of creating a part, for example, with an Inventor. And it's nice for me to be able to leverage these other people that are out there and access their ideas and their knowledge. So this is a little bit about me. I'm a solutions team manager at Imagine It. Like I said, I've got a team of 6 that I work with that report to me. And what I focus on is the manufacturing software, which is what we're taking a look at today. We've said Inventor a couple times, but it's really going to be the one part of that Inventor suite, which is the Fusion 360. That's where we're going to kind of go and pull some of this in. I'm focused on that manufacturing software, also the data management tools, such as Vault. I'm working on several different companies right now. And I've been with Imagine It. I should update that. I think this is my 20th year I'm in right now. So over 19 years with Imagine It, and then my 20th. So I've been around a little bit. Started in the way back days on mechanical desktop, and I did AutoCAD training, mechanical desktop training, moved on to Inventor, Fusion, AutoCAD electrical, worked with a lot of different tools. That picture you see there at the right, that has been my view for the past several months. Ohio has fairly recently lifted some stay-at-home orders, and we're able to go back into the office and some things like that. But my kitchen table, that would be my laptop, my 3 kids, and my wife. And there was a lot of, my wife teaches 2nd grade, so she was teaching 2nd grade from the table, and we had a freshman, a junior, and a 2nd grader all doing their classes there. So one day we were set up like that, and I'm like, oh my goodness, what a picture. So I'm sure many of you are experiencing, yep.
Your screen is not advancing.
It's not. Okay. I'm going to switch back, Glennis. Just switch back and forth.
Okay.
Hang on. I think I may know. Give me just one moment. Let me know if it catches up. And thank you for catching that. Someone is probably down there saying the same thing. I cannot see where. Do we have a screen of all my computers now?
No. There we go. There we go.
Caught up. Okay.
All set.
All right. So as I mentioned, I've been with Imagine It 19 years, and you would think after all that time I would remember to hit the share screen button occasionally. So thank you for whoever caught that. That would have been a very boring presentation of me talking and claiming things. So as I said, that shot right there, I'm sure a lot of people have seen something along those lines where everyone's working at the kitchen table, and we've all kind of struggled with that. So, it's definitely one of those things I'll remember for years, is sitting there watching my wife teach second grade from our kitchen table. So, one thing we're going to start talking about today is this idea of generative design, and really coming down to generating multiple versions of these. Looks like my screen's catching up now. Oh, job. Okay, hang on just a second. What? Okay. Looks like my screen caught up there finally. So what we're going to talk about is generative design. And here's what I want to talk about a little bit with that idea. This is going to be different from what we would think of optimization. So coming from Inventor and working with Inventor, optimization is something we have done forever. No matter what design you're doing, no matter how you're working on it, we try to optimize things. And the way optimization works is you start with a basic concept or design, right? We have a component, we have a part that we say, this is what I want, this fits the bill, now I'm going to go in and refine it. And the ways we may refine it, we want it to weigh less. I don't want this big, heavy plate. Maybe we're going to reduce it a little bit. Maybe we want to look at less expensive materials, or find a way that, yes, it works like this, but gosh, could we just, instead of doing a casting, could we weld it together? And all of those ideas, the tools that we typically use for that are going to be, one is just trial and error. I built it, and I think I can build another one that will work, so I'm going to give it a shot. Let's see what we think when I build it, and does that one work, and go with another one. And if you do enough trial and error, you get experience. And hey, when I go to build this component, I know that we need to at least start here, or I know it can't be anything less than this, or whatever else it would be. And in recent years, we can optimize with FEA tools. And that's a shot from Inventor where we have the shape generator, we define constraints, we define load conditions, and we take an existing part, and an Inventor can go through and begin to lay out a mesh that basically says these areas have to be here. You can begin removing some of the others so that we've got a lighter weight part, and we can work with that. So some of those tools exist in Inventor today to optimize. Now, realistically, this is probably a good indication of how we actually optimize, right? It's rarely with that huge level of intent and all of those ideas. A lot of times it's literally just hit and miss. We're going to give it a shot. B12, and we can sink the battleship or not. And we find that area, and with experience, you get a better sense of where things are going to be and what that's going to be. But it really comes down to we're just guessing. Or optimization goes just another way altogether. And as I was putting this together, I was reminded of being in when I was in college, and one of my professors who gave us the idea of when in doubt, build it stout, right? Look, we're not going to optimize this thing. We know that if I build this base out of these really thick tubes, it's going to hold. So that's one less thing we have to worry about. We're not going to concern ourselves with it. So optimization is so often either simply trial and error, we're guessing where things are, we're going to figure it out that way, or very commonly, let's just build it thick. Just that plate, that'll hold anything. We don't have to worry about it anymore. So that's kind of traditional optimization and the way we would approach some of those ideas within there, being able to go in and work with those tools in that way. Now, what we want to look at today isn't the idea of optimization. We're going to look at something else. We're going to look at the idea of generative design. So this is really different than what we would think of as taking an existing part and optimizing it. With generative design, we're going to go for a different approach. And it's an evolutionary approach that comes into place here, where instead of designing a part and then figuring out how to lightweight it, or designing a part and then going through and saying, well, could we make it from a different material? What's a good way to do that? What we're going to do is set it up so that we're only describing the function of the part. So we're going to, instead of modeling the component, we're going to model places for mounting points. We're going to model space restrictions. We're going to give it constraints. We're going to give it specific loads that we expect this to be under. We can define material. We can define the manufacturing process. And then we're going to let the computer, in this case, we're going to work with Fusion 360. We're going to let the cloud, we're going to upload it to the cloud and let it grind on it. Let Autodesk servers figure out these options. And it's going to be able to go through based off of that and give us options. So this is a completely different way of thinking about it. Instead of optimizing a part that I've created already, I've got the design already. Nope, I'm saying this is what it needs. This is what it needs to do. Mount here, skip this part. Let's see what we can do. And years ago, when I was first introduced to the idea of industrial design, one of the examples that I was given was the idea of concept sketches. And this is something that kind of doesn't exist within the mechanical design world. We don't go through just hundreds of iterations of a part before we come up with the best one. We start looking at form, fit, function. We put that together. Maybe you've got a few variations. Maybe you come back and optimize it. But in industrial design, they'll just start sketching. They're like, well, it could be this, it could be this, it could be this. What if we did this? What if we did this? And they'll just throw out all of these different iterations of the component. We don't really have the time to do that. When we're trying to get a design out, a lot of times we can't just come up with 100 iterations and then get together and pick the best one. The idea of generative design, instead of the user coming up with hundreds of iterations, we're going to let the computer come up with those hundreds of iterations, or dozens, whatever it may be. But based off that information, then, based off of that, we're going to go through, refine what we're looking for, evaluate that information. So it's typically going to flow something like this. We're going to start out with setting up some of the concepts, constraints, and goals that we have in place. So the concepts would be it needs to mount in this area. We have constraints of we don't want to fill in this. We've got an area that we have it for our design space that we don't want filled in. And then we're going to have specific goals that we're going to work with, such as I want it to be made of aluminum. I want it to be made with a 2.5-axis mill. I want this to, I've got a 5-axis mill I want to do it with, and it's got to be out of steel. Those are the things that we're going to set up. And I think this is something, as I've heard of this idea of generative design, we are offloading these concepts, this information to a computer. We're offloading these algorithms and these different things to a computer system. But what we're going to be doing is we're setting all of that up. Then we send that up to the cloud. It's going to come up with multiple designs, and it does it through algorithms and through different evolutions of that design and figuring out just all these different iterations based off of the information we put into it. Then, and this is the performance side, we come back and we take a look and begin saying, ooh, that one. Or, oh, none of this turned out the way I want. I've got to change a few things. We're going to change some space claims, or we're going to change some areas where it mounts, or we're going to change these different areas where it's at. So when we do that, this doesn't remove the human element at all. It just allows us to use an extended brain to come up with some of these ideas. We're going to offload those hundreds of concepts to the computer and let the computer come up with those so that we can come back and we can select the best one. Now, I mentioned earlier that there was the idea we had said this is going to be done, we said we're going to multiple designs using Inventor. We're going to be using part of the Inventor. The Inventor's part of a suite of tools. There's the different, there's the And suddenly the word escapes me, but there's the package that Inventor comes with. And one of the tools that's available in there is a tool called Fusion 360. And Fusion 360 is something that I've had people ask me, like, well, when do I use Fusion 360 compared to Inventor? Should I use it instead of Inventor? You know, what does it do? And at a glance, I can do a lot of the same things in Fusion 360 I can do in Inventor. I can create some models, I can create some drawings. I'm going to tell you that Inventor is still probably the stronger tool for creating manufactured components. What we're going to do, though, is leverage Fusion 360 to give us all of that other information so that we can have all of those multiple variations of that. Now, my space claim, my mounting points, all of that can be modeled in Inventor. We can then upload it to Fusion 360 and begin running through the iterations and setting up those remaining constraints, the points, the loads, whatever else we would have on there. So I'm going to walk through this a little bit, and I'm going to use I've got a component that I'm going to set up. I'm going to give some of these different areas so that we can see some of this. And then once we've got that in place, I'll pull up one where it's completed. I don't want to take the time to run this. This could take hours and hours to run all these iterations. I'll point out when we come to that area where I would run it, and then I'm going to jump to explore some of those design variations that we have on there. So I'm going to drop out just for a second and pull up my Fusion 360. Okay, so I've got my Fusion 360 open, and I'm going to be going through and taking a look at a particular file that I have in here. So I'm going to go ahead and open up this file within my 360, and it's this motorcycle clamp that I'm dealing with. So this is really strange when I first take a look at it, because this has very little to do, as I look at this, with what I want this motorcycle, this doesn't look like a motorcycle clamp at all. Instead of the motorcycle clamp, what I'm going through and setting up is a space claim that I have. I'm going to have certain bodies that it's going to work between. I'm setting up points that we're going to mount to this. And in here, I'm in the Generative Design workspace. And I have multiple workspaces within here. I've got design and render, animation, simulation, so on. I'm in the Generative Design workspace within this tool. So I've got this set up, and I've already got a few of these pieces in place. I want to take a look at it a little bit. So if we take a look here, I have preserved geometry, and I've got obstacle geometry. So my preserved geometry are these areas that I've created. That I want to stay. I'll just turn it off and on a few times here so we get a sense of that. That is what has to be there, right? So those are my mounting points that I'm concerned with. I also have some obstacle geometry. And again, I'm turning that on and off as I go through just so we can kind of see what we're looking at. And the obstacle geometry is areas to avoid. And again, of course, this can be modeled within Inventor. That's no problem at all. I could model it here, I could model it there, but I want to go through and begin setting that up. So I've got those components as part of that. I actually have a couple others in here as well. So I've got the different forks, and then I've got a couple of bodies over here that I have turned off. These, I'm going to turn on here, and they take up a lot of space. That's why I'm being kind of cautious with it. But when I turn these on, these are the areas of my constraints. It has to fit between those components. So what we'll see is, as I go through and do this, I'll turn them back off just so we can see the rest of it. That's what it has to fit between. So I'm defining a lot of different things. And to me, it's almost like designing backwards. I'm not designing the clamp. I'm designing the areas the clamp can and cannot go, and I'm designing a limit on how large and small it can be. So I have obstacle geometry, I have preserved geometry, and then I've got a couple of bodies that I'm using as limits for that. So then I have different things set up here that are going to be in terms of some objectives that I have. So I want to minimize mass. I have this as one objective within here. I want to minimize mass, and I have my safety factor set to 2. So based off of those rules, we're going to let the computer generate some information for me. And if you've seen generative design in the past, this is something that would come up fairly often where we would have generative design and different things. A lot of times what we would see is it would create a part for 3D printing. And it would create these really strange or interesting organic shapes as it went through. And that's great for concepts. It's great for a lot of times we'll have components that we're creating for consumer products, and we want all of those different shapes. But when it comes to really manufacturing a piece, a lot of times I don't want to use those manufacturing methods for additive manufacturing. I want to use some standard manufacturing methods. So Fusion 360 allows me to determine different manufacturing methods that I want to take a look at here. And I've got a few that I'm starting to set up for this. So I am going to look at additive. I do want to get a sense of what that looks like. And I can determine different materials that I want to use for additive. So, what if we used additive and we had this made out of aluminum? What would that do for creating that? So additive is pretty simple. I don't have a whole lot to do in terms of that. I can simply say, yeah, we'll work with an additive part. With milling, it's a little bit different. I'm going to have some options that I have with milling in terms of I've got some other materials that I'll be taking a look at with that. So I've got more materials. And then I'll come in here and take a look at 2-axis cutting and how I want to work with that. And again, I've got my material libraries, I've got my different manufacturing methods that I have, and I'm going to set a few other pieces up with that. So let's take a look. As I go through, I've got my design criteria, and I'll take a look at manufacturing, and I'm going to say additive is fine, but under milling, what do I want to do? I'm going to deal with, I'll include 2.5 axis. I have a minimum tool diameter and a minimum wall thickness. So all of these constraints are still things that I'm setting up and I'm concerning myself with. I've also got a 3-axis machine. And again, I've got a minimum tool diameter. I've got my tool length that I have in here, shoulder length, my head diameter, cutting direction that's going in, what does that look like? And just to keep things interesting, I'll throw in a 5-axis as well to see what we could do with that. As I look at this, I remember when I first started working with 3D, and it was kind of moving from 2D to 3D, and one client I was working with used the phrase, he said, I don't think I could design the component that I just did. It was a port, it was a multi-port item for, it was fluid. It filled fluid into radiators. He said, I don't think I could design this using 2D. Like, I'm able to leverage 3D to create a design I don't think I could do before. For me to sit down and say, okay, what if I built this part for 2.5, 3-axis, and sure, what could I do if I had a 5-axis in there? What could I change about it? That is so much information and so much addition and changing. I wouldn't. Is the simple part. I simply wouldn't do it. If I wanted to add a new configuration to this, I can come along, put in a different configuration. I could say, well, what if we had a 2.5 axis? I could change my tool diameter or my wall thickness for that to give me more options, right? So I could look at what if I was using different tools. So I can add and remove configurations and update all of those pieces in there. So that's my milling. I am including my 2.5 axis cutting, and with that it's just my 2-axis cutting, so it's just got a simple cutting direction in there. And then I have die casting, So I can say, what is the ejection direction for that? If I have a die cast, which way does it come out? What is my minimum draft angle? What is my maximum thickness and my minimum thickness on there? So for each one of these different methods, we're going to be able to run iterations of this and see what this would look like if it's done with those different methods that we have as part of that. So I've got my areas that I'm going to avoid. I have my areas I have to keep. I have all of these different iterations that I'm going to go through to look at what if we did it this way, what if we did it that way. I've got some materials that I'm doing each one of those from. And then the other type of design criteria that we would begin to add would be design conditions, which are different structural constraints. So I could fix certain areas, I could put pins, make a pin constraint, I could put frictionless components in there, saying, it can slide along here. And then I also have structural loads, whether it's a force, pressure, a moment load. If I've got a torsion on there, what does that look like? Bearing loads. So this is along the lines of what I would do with an FEA model. Typically, though, with FEA, I want something to work with already. I've already designed something, and I'm looking for failures in the thing I've designed. In this example, with generative design, we're not dealing with that. We're starting out with the idea of, this is the type of loads that are going to go on this. Hey, computer, you tell me what makes sense with that. So those loads are already on here. I've got I've got a couple torsion loads that are part of that. I've got gravity, a few forces that are coming in as part of this. And I also have some tension as part of that. So I've got some specific loads on here, defining some forces. And then I've got some constraints in a few places determining how things are fixed. This cannot move. That's a fixed point within there. Everything else can move around, but those are fixed. And we'll see that. I'll see that with all those different loads. So I would go through, define each of those characteristics, and then I'm ready to go. I can generate. I can begin sending this up there. So I can say, let's take a look, and I'll run a pre-check here. So when I run the pre-check, it says, hey, there's a couple of bodies out there that are turned off. And that's those two bodies that I showed a moment ago. These are some areas that we have where I'm not as concerned with, I'm in here and I want to maintain that it can't be any larger than that. So those are just some constraint areas that I have as part of that within there. So it's not a, I had them turned off just mainly for visual purposes. Before I run it, I did a pre-check and it warns me, hey, make sure you turn those on. And now I can begin going and previewing some of this information. So this preview will take just a second. I may even cancel it here in just a moment. Actually, I'll pause it here. We'll let it run for a second. The previewer starts to give me, and it gives me kind of a blob, is what it comes out to. It gives me a sense of what it's going to go for. So this is using some cloud computing to go in and do that, run that, and it's going to take longer than I'd hoped. So, we're starting to see it beginning to generate the preview. We're getting the sense of that being built up in there. So it's looking at those constraints, looking at that information, and it's beginning to generate that as part of it. And it literally is. It's going to look like a blob. It's not going to look like a finished part right now. But this is kind of a way to check, am I on the right track? Am I blocking off the areas that I want? Is it holding the places that I want it to hold? Am I avoiding the areas I want to avoid? And once we have some of this, then I can begin running an actual study on this, that we can then go and explore these different concepts once we have that. We're almost done here at the preview. I'm going to allow it to finish, and then I'll take a look at that preview a little bit. There we go. So we've got our preview in place. I'm going to turn these bodies off, and I get a sense of what we're going to start building. Right? So it's going to be constrained by those components that I have, by the areas that I have. It's going to definitely include some material, definitely ignore other material. That's kind of what I want, right? Even even as I look at that, what I'm going to end up with here is this is a motorcycle fork that we're looking at, and this is going to be a component that holds all of that together. It's going to be this link that we have to hold all of that into place. So if I were to look at it in this attitude, something like that, yep, that's kind of it. That's along the lines of what I want. Definitely not my finished version, but it gives me a sense of, am I going the right path? Now I can go through and I can generate. So when I generate, yep, it'll stop the previewer, that's fine. And it's going to run a study, it's going to go through and do this, and it's typically going to consume cloud credits. I believe it's 25 cloud credits per study. Cloud credits are something from Autodesk. You have a set number of cloud credits with your account. I think these typically take about 25 cloud credits per. Interestingly enough, and I noticed this when I was running this a while back, I've been randomly selected to be part of a test that I don't have to consume cloud credits. I have no idea. This is something you would have to look to see if you were also randomly selected, but it's just kind of interesting to me that sure enough, there are these, this is available. I can generate this study from that. Now, I'm not going to, and part of the reason is, just for the preview that you had there, you had a sense of how long that took to go through and open that up and get to that information. I'm going to close this out, and I've got kind of the finished version. So we're going with that cooking show approach where I've already got a version in here that has been finished so that I can go explore the outcomes that we have available. And what I did is I brought up my data tab. This is just part of Fusion. This is some data that I have in here. And I'm going to look at that motorcycle clamp. So it's a motorcycle triple clamp. Looking at the forks, holding that. And this is a study that I've run, and I'm going to go ahead and open up this file. So typically, while this opens, I'll just kind of go through, what I typically would have done is I would have hit generate, and I just would have let it go. It would have kind of ground through on that, pulled up gone through and looked at all the different options that were available based off of all the rules that I've set up and that I've given it so that we have those in place. And I just turned off my data panel, so I'm just looking at this information. And now I'm going to go explore those results. This will take a moment to come up, and we'll be able to look at this in quite a few different ways. And we're going to be able to filter this in a lot of different ways. So I said we had to have a minimum safety factor of 2. That was one of the things that I had told it. That's kind of the first thing that it comes up with here is I can begin going through and looking at some of these different iterations based off of that. What I'm interested in, I just want to look at all of them. So this is kind of just a table view of all of my study outcomes. And it is, I'll just add them all in here. So we'll do unrestricted, additive, 5-axis, die casting. And you can see how it generated all of these different previews for me as part of that. And I can take any one of these previews and just go take a look at it. So here's one that was done with additive. I want to take a look at this particular design. This would be if we're using additive manufacturing. And it is, again, because it's additive, we've got these really organic shapes that it comes up with. Notice some of the shapes are not organic. Those are the ones that I had pre-specified. We have to have this. We have to avoid this. You come up with the rest. So in this case, I've got one here that's just, that's interesting. I don't know what this lump is over here to the side. I mean, I don't know if I need that, but we would want to refine that and look at some of that. So that's interesting. We'll take a look at that one. I'm going to begin filtering through this a little bit. And I'm going to say, well, what if I said, I just want to look at 2.5-axis milling. What did you come up with for that based off my information? Because this is something I can do in my shop. We've got we can run 2.5-axis mills there. And doggone, that actually looks a lot like a component I might generate. As I take a look at that, it's lightweighted. I'd probably clean this up a little bit. I don't know if I want that quite that way. Maybe I need to make a few more adjustments. But it's got pockets. It's got my information. It's got all of that within there. Let's take a look at one more of those. Again, this is aluminum. It's just a different study. So this is just one more iteration that it went through and came up with. Oh, that definitely looks like something I would design. Probably about the concept that I would come up with. It's got these interesting undercuts, but they are symmetrical this time. I like that. It's got some pockets to remove the weight. So it's that. I would probably keep it as simple as possible and do that one. But that's interesting. You know, we got some different ways to remove some weight and some different things that are part of that. I can just continue looking at these different studies. For instance, I'll do the same thing, just look at one from titanium. Of course, you've got titanium has different material properties that we have in there. So we can, I like that too, with the rib that's part of that. You know, it's milled out. So at this point, this is where that human factor really comes back into it, because now it's up to the individuals to say, well, what do we want? You know, how much effort do we want to put into this manufacturing? How much do we want to spend on the materials? And I can just kind of keep going through and looking. I really like looking at the manufacturing methods because there's so many different ways of doing it. For example, here, I'll do an aluminum one that came off that would be done with a 5-axis. So now we've got a lot more options for doing undercuts, and yeah, that looks expensive. As I look at that, that's a lot of manufacturing. Depending on what type of motorcycle I'm creating here, I'm more of a 2.5-axis guy apparently, because just looking at that, I'm like, wow, it's a lot of effort. But it wasn't. What I really, it's a lot of effort to manufacture, but to come up with the design, I didn't have to do that intense level of work. I was able to define those areas and look at that. I'm going to take a look at a different view, a way of viewing these. So if I jump over here and turn all these back on, and this is just a list that I have of those different options within there. And here on a scatter plot, I can review things by maximum displacement. Where are we at? I can see higher levels of displacement based off the rules that I have and lower levels of displacement. My same filters work here, so I can say, well, show me, that 2.5-axis and what levels of displacement. So those two are really close together. And as I look at the thumbnail that I have there, I can see where that's at. Well, what about my safety factor? We've got these are generated along my safety factor, so that works. And I can look at the other options that come along with that. And again, it's just a different way of viewing that within here. I've also got properties views, which gives me I can sort these by manufacturing method. So here's all the ones with my 2.5-axis. Here's all the ones with 2-axis cutting, 2.5-axis, and then it comes down and shows me all the different properties that I have within there. So I really kind of like that one. It's titanium, so it's a little expensive, but at a glance, I like the way it looks, and I can begin exploring that. So this is a key part of this process. Here's the initial setup, the generation, and then we come in and we can begin exploring all of these different iterations within it. Take a look, and this is just a simple thumbnail view. It just gives me all my thumbnails, and I'll just throw this in so we can see all of them. We can see all the different versions that it came up with. Drop down here and just look and say, well, what if we did a die-cast version of that? And here's a couple of dies that we would have that are part of that. So again, the idea is the initial setup is all done by the user. All of the constraints, all of the boundary conditions, all of those different pieces that we have within there. Once we've gone through and done that, we use Autodesk Cloud Credits to generate all of these different versions, and now we can begin looking at it in a whole bunch of different ways so that we can preview the information, take a look at the status of it, and begin to view that. To generate all of those, that's several hours. I can't remember what all it was. I just kind of hit it and let it run and took a look the next day. It will begin popping up. As it generates them, you could look at Explore, and because you notice I have one called Processing Status. And I've got, these are the ones that are completed. Converged is where it's brought a few different iterations together to create a complete converged version of that. So, and as you go through, you'll see some that are saying, unfinished or processing, excuse me. You'll see some that are currently processing as we go through and see that. I can filter further. I'll just jump back over here, and I can say, well, what if we show me all the ones that are within this safety factor, within this safety factor. Let's bring that floor up, to 2. What are the ones with 2 to 2.46? Piece part, cost. We're not, we're how much we're going to pay for this thing, right? All these different ideas go into it, and it's using a priori, which is an external service, to come up with some of these theoretical costs for running that. You might have noticed that when I said I'm going to run this at 500 pieces, that's kind of where that information is coming from, based off of some concepts that are in there. Again, you would have to look at yours specifically to know exactly how much it's going to run, but it'll give you a sense of it. That's really what we're looking at. So this is what I started with. Very simple geometry. This can be created in almost any tool set that I have. Right? This can be created with an Inventor. I honestly probably could have created it in AutoCAD and saved it out as an STL file. Once we bring it into Fusion 360, we can run that generative design to come up with all of these variations from it. Let's go back here to my thumbnail view so we can see that. That's what we're generating from it. So we're designing the inverse. We're starting with what our rules are, and then we're letting the cloud determine different variations on that. And of course, once I have it, from there it's up to me. I can say, well, I'm going to take this particular study, grab this outcome here. I'm going to grab this particular study. Yes, I am. And now I want to take this and begin saying, well, I want to download that to use as a basis for a design. I could also come in here and compare it to another version. So I could say, well, let's do a compare, and we'll compare it to this one. So I can see them side by side, and then I can turn on and turn off. This is my obstacle geometry. This is my to-keep geometry. So I can clearly see how I got here. I can run different versions side by side and look at which one I want to use. Then I can take those studies and begin using them as a basis for creating components out of that. So this is the idea behind generative design. Just like with data management, we're going to let the software handle, maintain, and remember the links between files. In this case, all of those iterations, just like with that sneaker that I showed, instead of me coming up with those iterations, we're going to let the software come up with the iterations between them.